Welcome to tonight's video on graphing trig functions, specifically sine and cosine. So to graph any trigonometric function, you first must know what the base function looks like. So the base graph of y equals sine x. In the equation y equals sine x, what does the x represent? Well, the x represents the angle. Because if you put like pi in there, sine of pi, pi is the angle. What does y represent? Well, y represents the value of the sine at the angle. So the x coordinate is the angle, the y coordinate is the sine of the value of the sine at that angle. So if we make a chart of all the quadrantal angles from negative pi to 5 pi. So negative pi, remember is negative 1, is 0 for sine. Then we'd go negative pi over 2, and that's negative 1. 0 is 0. Positive pi over 2 is 1. Pi is 0. 3 pi over 2 is negative 1. 2 pi is 0. 5 pi over 2 is 1. 3 pi is 0. 7 pi over 2 is negative 1. 8 pi over 2, which is 4 pi, is 0. 9 pi over 2 is 1. 10 pi over 2, which is 5 pi, is 0. So then if we graph those functions from negative pi to 5 pi, so 0, negative pi over 2 is negative 1, 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, 2 pi, 0, 5 pi over 2, 1, 3 pi, 0, 7 pi over 2, negative 1, 4 pi, 0, 9 pi over 2, 1, and then 5 pi, 0. So notice when you graph it, it looks like a wave. There you go. And it keeps going on and on like that forever and ever. So knowing that we can travel around the unit circle infinite many times in the positive and negative directions, the domain for the sine graph, because it's an angle, is negative infinity to infinity. The range, if you look at the y, the lowest is negative 1, the highest is 1. Notice that the graph repeats, and where each repetition is called a cycle and is known as the period of the graph. What is the period of the sine function? Well, if you look between 0 and 2 pi here, notice that is unique, and then it repeats itself afterward. So the period of the sine function, the period of the sine graph, is 2 pi. When talking about this graph, we also discuss what's called amplitude. That's the height from the center line to the peak or the valley. So here's the center line, right? The center line is the x-axis. So what is the height to the peak and to the valley? And that is 1. So the amplitude of a normal sine graph is 1. Whenever we graph the equation, we will graph the function, and so the 5 ordered pairs in order that occur between 0 and 2 pi are 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. Those are the 5 coordinates that occur within that rectangle of 0 to 2 pi. All right, so then cosine. Remember, x represents the angle. y represents the value of the cosine of that angle. And we'll do the same thing. We'll make a chart from negative pi to 5 pi. So negative pi over 2, 0, positive pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. So I went ahead and filled it in. So negative pi, the cosine is negative 1. Negative pi over 2, the cosine is 0. 0, the cosine is 1. Pi over 2, 0. Pi, negative 1. 0, 1. 0, negative 1. 0, 1. 0, negative 1. So when you graph negative pi, the cosine is negative 1. Pi, negative pi over 0, 0, 1. So we'll put the points down. All right, so once again, notice it's going to be repetitive. So the domain of the cosine is negative infinity to infinity. You can put any angle in. The range, once again, is negative 1 to 1. The period of the cosine, if you notice, from 0 to 2 pi, it starts here, goes down, and then up, and then it starts again down, and then up. So the period is 2 pi. The amplitude is 1. And then the points from 0 to 2 pi that we should remember, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi and 1. Those are the 5 points that occur between 0 and 2 pi. So for the next part, you want to get out your graphing calculator and look and see, okay, when you graph sine x, so first of all, you got to go to the window and you want to make it, you want to make the y, the x window 0 to 2 pi. So you put 0 for the minimum, and then for the maximum, you put 2, and then the pi key is up here, so you got a second function, pi. Don't worry about the scale. The y minimum, you want to put negative 1, and the y maximum is 1. All right, then we want to go to mode, the calculator for mode, and we want it in radian mode, so notice it's already there, but if yours is in degree, just highlight radian and hit enter. And then we go to y equals, and we're just going to type in sine x. Hit enter, and then graph. So notice there's one cycle of the graph, right? Sine x. You see one picture, the period is 2 pi. So notice now we're going to change it to 2x. So you go here, and all you want to do is change it now to 2x. And graph it, and notice now you see 1 revolution and 2 revolutions, or 2 periods, 2 cycles. So the period where it repeats itself, well, if you notice, it repeats itself now right here in the middle, which is pi. So now let's make that sine 5x. And then graph it. And now you see a whole bunch. 1, 2, 3, 4, 5. So there's 5 cycles or pictures. And the period is now 2 pi over 5. Now it repeats itself quicker. So if you put a half in, if you put a fraction, like let's do 1/2. So we gotta go 1 divided by 2. Sorry, let's get the calculator. Go in here. 1 divided by 2x. Okay, graph it. Now notice you don't even get a full cycle. You don't get a full cycle. You get half of a picture. So the period is actually going to be double. It's going to be 4 pi because it's going to take twice as long to repeat. And notice if we put a 4th in, and you graph it, doesn't even come close. You see a 1/4 of the picture, and that means the period is going to be 8 pi because it's going to be 4 times as long. So whenever the period shrinks, we call that a horizontal shrink. And the period here, because there's a 3 there, it's going to be 2 pi over 3 because it's going to be 1/3 less, or 1/3. So you're going to multiply 2 pi times 1/3, or 2 pi divided by 3. This is called a horizontal shrink by 1/3 because you can see 3 pictures of the sine graph when you graphed it. Since the base is 2 pi, the period is 2 pi over 3. Therefore, it's a because you went 2 pi times 1/3 to get the period. Without graphing on your calculator, determine the period of sine 1/3 x. And notice since it's 1/3, it's going to be bigger by a factor of 3. So 2 pi times 3 is 6 pi. Since we can see 1/3 of a picture, that means the period is 2 pi and it's stretched by 3. So 2 pi times 3 is 6 pi. So the general equation to find the period is 2 pi over b. So notice 2 pi over 1/3 gives you 2 pi times 3, which gave us the 6 pi. All right, let's try this with the cosine. Actually, sorry. Let's do some examples. You can do some with now the amplitude. So let's put a number in. Now we're going to change the window to whatever the a is in your. So notice if it's y equals a sine bx. If there's a number in the a position, the window is going to be negative to positive of that a. So the window here, it still says 0 to 2 pi, but now it's going to be -3 to +3. And it's y equals sine 3 sine x. Sorry, y equals 3 sine x. And you graph it. So notice it goes up higher and down higher. All right, so the amplitude now is 3. So if you graph 2 sine x, you just change it to a 2 and graph it. Notice it goes up to 2 and down to -2, so the amplitude would be 2. Same thing if you put a half there. So if you put 1/2, so notice it doesn't go up or down as much. It goes, the amplitude's 1/2. And you could probably guess, what the amplitude is going to be here. It's going to be 1/3. So without graphing on your calculator, the amplitude would be 3 here. So the vertical stretch by 3 because the amplitude's going up or down. If you're multiplying by a fraction, then it's a vertical shrink. because the distance from that you go up and down is shrinking. So the amplitude is just the absolute value of the a term in this formula. All right, you can do the same thing for the cosine. I'm not going to graph it. You can graph it on your own. But notice, if you do this, how many pictures do you see? You see 1, and the period is 2 pi. And then the same thing here, 2, and the period would be pi. And 5, and the period would be 2 pi over 5. So you should notice and see that it is the same as the sine, the effect that that number has in front. And then if it's 1/2, you see half a picture, which means the period is 4 pi. And if it's 1/4, that means you see a fourth of a picture, which means the period is 8 pi. And then without determine the period without graphing, well, remember it's 2 pi over the number, so it's 2 pi over 3. And that is called a horizontal shrink by a third. And if you have a fraction, then you're going 2 pi over 1/3, remember, which is 2 pi times 3, which is 6 pi. And that is a horizontal stretch by 3 because you can see a third of a picture, which means the period gets longer. So to find the period, it's just 2 pi over b, just like the sine. And then for the vertical stretches and shrinks, just like we did for the sine, this number here will determine that. So the amplitude would be 3, 2, 1/2, 1/3. So if it's a positive number, if it's a number greater than 1, it's a vertical stretch because it goes up. So if a is greater than 1, it's a vertical stretch. And if a is between 0 and 1, it's a vertical shrink. So here it'd be, the amplitude would be 3 and 1/3. So in general, it gave you the formulas. For the period, it's 2 pi over b. For the amplitude, it's a. So one thing to keep in mind, and let's go back one page. For horizontal stretches and shrinks, remember we talked about here, so it's a horizontal shrink. If b is greater than 1, it's a horizontal shrink. And if b is between 0 and 1, it's a horizontal stretch. So it's reverse of the vertical. All right, so that concludes our video for tonight. If you have any questions, feel free to ask in class. Have a good evening.